So hello, if you're just joining us for the SXPA288 Labcast from the observatory on Mount Teide, Tenerife. We're just waiting for a few people to arrive, so we'll quiet a moment, you'll be able to see us, and you'll see we're filming with a computer here. Have a look at the map widgets and the other widgets when you're ready. We'll start in about 1 minute, I think. Okay. We'll just do a sound check as well. If you could suddenly give me some feedback in the chat window just to indicate that you're hearing the sound okay, that would be very helpful, thank you. Excellent, got some feedback on that now, thanks. There's a bit of a delay that you may detect us having to deal with. It takes about 20 seconds, 20 to 40 seconds from when we look into the camera and say something and you get it. But when you type, it comes to us instantaneously. We're happy to use the chat window this evening. We'll just be here for about half an hour. We haven't started yet, this is still just the welcome warm-up. If you have a question to pose, you can put it there. It may start, if everybody asks a question at once, it'll whiz past us. But I've got two colleagues here, so we'll try to keep an eye on it. And let's make this a little bit interactive if we can. Okay, I see at the moment that we've got 18 people in UK and Ireland. We've got 2 other EU, one of that is us, so that's actually 3 of us. And we've got North America 1. That's fantastic. Hello, North America. Not dark there yet. It got dark here at about 6 o'clock, and we're on UK time here on Tenerife because it's quite a long way west of mainland Europe. Even Portugal actually uses GMT at the moment.
You wish to comment on the
Yes, I see. Noise. Okay, I'm sorry about the motor noise. It's the fan going on my laptop. Maybe I'll try to talk a bit louder. That will help. We tried to eliminate it earlier, but we couldn't. I see it's just going past 1/2 I'm going to risk starting now, and any latecomers can join in. So hello, I'm Nick Braithwaite. I'm the module chair for SXPA288 Physics and Astronomy. Practical Science Physics and Astronomy is the actual title, isn't it? If you're watching this, because it's being streamed also live over YouTube, you're welcome to stay watching if you're not actually doing this Open University module. But bear with us because we're talking to our team right now. I'm joined here by Ulrich Kolb and by James Smith. Ulrich is a colleague of mine in the Department of Physics and Astronomy, and he is a practicing astronomer. James is a colleague of mine on the Open Science Laboratory, and he has been a practicing astronomer. So we just thought we'd do a labcast from here because we were coming here anyway to visit the Bradford Robotic Telescope. That's an autonomous telescope. Some of you may have been using it for backup data if you were given a night on Pirate that turned out to be cloudy and you didn't get good observations. There was that option to put in a request of the Bradford telescope. And we've just been up there today. We've actually been changing a hard disk for them. And we've been in and seen the telescope. It was still light then, so it wasn't actually working, but it's probably right now doing some work gathering some data on the night sky. So I'm going to ask Ulrich, first of all, why is there an observatory here?
Well, this is one of the premier sites, certainly in the Northern Hemisphere, for placing an observatory. It's very high, but the altitude is about 2,400 meters, which brings it well above all the nastiness in the Earth's atmosphere, the clouds, the water vapor, dust, human effects and lights which
Ah.
just went out in this building.
Okay,
Interesting
we
enough.
should have some glow still coming
Oh.
off our screen, and we got the lights back on.
Back on.
Okay.
That's possibly even
Maybe because
a
we didn't
very-
move.
a very short now, but could be that as well. And yes, so back to the question then, we are here really high at the mountaintop observatory, as they are best placed to be not closer to the stars, but above the perturbing layers of the Earth's atmosphere. The other advantage of being here is it is far away from most human settlements. They are well below us, and there are only a limited number, those people living on Tenerife. All facilities here are now well connected with very good internet connection, and there's a support astronomer on call and on site. So it is a proper professional observatory with all the amenities, including this building we are in here now, where we can broadcast to you, and in fact also later on retire for the night.
Yeah, we're in the residence building right now, and as we drove up this afternoon and came around one particular corner, climbing up the road, suddenly got a view of the edge of the observatory with some tall towers and domes painted very stark white against the landscape, just cutting the skyline. Excitement began to grow, and we only saw a little bit of the site then. We eventually came around and got onto the site, and there's a lot here.
There's a lot here, and I wanted to add to what I just said. The probably most important reason why this is a good site is that it has an enormous amount of clear nights. 80 to 90% of the nights are usable clear nights for observations with telescopes here, and that's a number to be found elsewhere in Europe. Probably nowhere in Europe, in mainland Europe, can you achieve this amount of clear nights. I think that's what makes the Canary Islands so unique.
So what's the drawback? There must be some downsides to being here, otherwise the place would be covered.
It
really
is.
bristling.
It is.
Well,
It is
quite a lot for an
covered.
observatory.
No, it is quite a lot for an observatory.
Yeah.
I did mention settlements before. So Tenerife is a popular tourist destination, as you may know. Some of you may have been here for holidaying. There is quite a lot of hotels and resort type of buildings near the coast, and this causes some glow and night sky brightness, which is a little bit higher than most very serious professional astronomers with very large telescopes would like to have. That's one drawback, and the second one is the seeing here at this site is moderately excellent. It is good, but it's not one of the best seeings you can get. And when I say seeing, what this means is the turbulence in the atmosphere, which causes images of stars to be not like a point, but like a little disk, and this disk may be perhaps a few arc seconds in diameter, so that's an angle measurement, an arc second, as it would be in Mallorca, for instance, where the Pirate facility is located, and I'm sure some of you will have used Pirate for your work. Pirate suffers from significant seeing. A few arc seconds is quite typical, it can be larger than this. So an immediate consequence of this is that if you have two stars very close to each other, as you would have in a dense star cluster, for instance a globular cluster, you would not be able to resolve the two stars, they would blend into each other. If you go to a site like Tenerife, the star cluster would appear immediately better resolved, because the seeing is not a few arc seconds or perhaps one arc second. But the really, really excellent sites on this planet would have seeings of sub-arc seconds, so half a arc second or even less.
Okay. That's a nice comparison with Mallorca, where some of our students, we've lost the lights again. We've discovered it's because we're not moving, so we will get up from time to time. But there's a question I can see coming in here which says about the climate, and it differs on each side of the island, and whether or not that affects things.
Yeah, I don't know. That's a level of detail I can't easily
We are
answer.
actually, we're quite close to the top here, aren't we? We're near the apex of a ridge, not on the top
we
of
are
the
on the
volcano.
ridge. We are not on the top of the volcano. We are on the ridge, or a little plateau, if you like. And there is certainly a microclimate, depending on which side of the ridge you are at, the wind will make a different layering of the atmosphere, and that affects the turbulence, the microturbulence, and it also affects the local cloud cover, if there is clouds rolling at this altitude, not that often, as I remarked earlier. If it does, it also depends on where exactly on site you are. Yes, the topography has some effect, but I think it's secondary to making the site, an excellent one. It's an excellent one regardless.
Okay, good. And somebody also is asking, John Baker is asking if there's any seismic activity. Well, we haven't felt any
so
yet.
far we haven't.
The volcano, I think, has been dormant for some time.
For quite some time,
Yeah.
which is not the case
Hundreds of years.
for volcanoes on neighboring islands. So I'm sure there is occasionally tremors and activity felt.
Now, James has actually spent time observing on La Palma, was it, the next time?
Yes, so La Palma is west of Tenerife, and before the UK joined ESO, the European Southern Observatory, La Palma hosted the UK's largest telescopes. So those are the largest optical telescopes that UK astronomers had access to. So I've done some observing on the 4.2 metre William Herschel telescope. I was looking at quasars, and in particular I looked at those in polarized light. So after the UK joined ESO, UK astronomers had access to the VLT telescopes. So that's four 10 metre class telescopes in Chile, and a lot of the work has shifted to there. But in some ways, when you go to observing on La Palma, you actually go there and you experience the whole process of going up the mountain, staying at the residence, using the telescope. With the VLT, often you send in a batch job to the telescope, so you do remote observing.
It's more like cloud.
It's more like Pirate.
Bigger, but more.
Bigger, but it's definitely more like Pirate. You do your observing plans from the UK, you then submit them, and they are carried out by professional astronomers in Chile.
Now, while you were on La Palma, did you have any seismic activity there?
No, thankfully no. But I mean, people may remember a few years ago there were these stories of a tsunami potentially hitting the eastern seaboard of the US, and the cause of that in various models was half of La Palma falling into the sea because of the dormant volcano.
Right. Yeah. Right. So there is some seismic activity is the answer to that. Now, could we speak a little louder is a question that's been put here. We can certainly try that. Yep. Sorry about that if it's going a bit quiet from time to time, possibly when we turn away from the microphone. So we'll try harder. Now, I just wanted to say as well, I see that there's solar telescopes out there and there's stellar telescopes. I didn't see any radio telescopes. Why haven't we got any radio telescopes here?
Well, radio telescopes do not really have a need to be sited very high up in pristine conditions. As we know from Arrow, from this module, they work remarkably well even if it's overcast or, goodness, raining.
Yes.
And therefore there's no need to site them in hostile territory where it might be expensive to put them up or complicated to maintain them. That's the main reason. The same can't be said for millimeter wave and infrared facilities, which sort of border between or sit in between the optical telescopes and the radio telescopes. They are desperate to go high up because there is lots of water absorption in the atmosphere, in the Earth's atmosphere, so they need to be really high to get the signal they crave for.
Okay, and there doesn't happen to be any sub-millimeter here.
I don't honestly know. You haven't seen any.
Right, okay. I'd just like to give a message, please, to the curriculum manager for SXPA288 to ask Peter if you could set up a little forum before the end of this Labcast, next to the Labcast on the study calendar page, in case there are any questions come in the next 24 hours or so from either people who are watching us tonight or from people who watch the recording that we'll place there. as soon as possible afterwards. And I'd also like to make an apology to my colleagues back in Milton Keynes on the technical side, because I forgot to do the start the recording. So we'll have to grab the recording from YouTube. But I think we can do that. Okay, now let's just think a little bit more about these widgets. I've got a widget down here that asks people if they've visited a professional observatory. Some people have filled that in. It looks like the majority haven't. Some have done an optical and some have done a radio. I don't know if you noticed, but you could actually fill in two answers here. So you could have said, yes, I visited an optical, and neither, if you'd wanted. I couldn't stop that happening, but I myself filled in that I visited an optical, this one, and a radio. I've been to the radio telescope at the Open University, Harrow. I've been to Jardrell Bank as well. That was that question. And then we put another widget up here which asked people, what did we ask? I'm going to have to lean forward and read the screen. I can't remember what the question was. Oh, why is astronomy so popular? Well, what is it so engaging for the general public about astronomy? And we've got some answers here about pretty pictures, exploratory, sense of wonder, I like that. Place in the universe, exciting. I tell you why I asked that question, because right now I know we're coming to the end of the first topic of study of SXPA288, which means that next week is TMA time. And in the first question of the TMA, we're writing up whether we did the colour magnitude diagram with the star clusters on Pirate, or on the radio telescope it was the intergalactic spiral arm structure. So there's a sort of standard write-up to do on that one, and there's a structure laid out, and I hope that your tutors will be giving you some hints as to how to respond to that structure. There's some tight word limits. Those are meant really to help you, because sometimes it's quite difficult to write short. So knowing how to pitch it, how to get it the length right is important. And then there's some images that we want, a couple of pages or so of images. Don't quote me on that, have a look at what it says on the website, but there are images, space to put images in. Bit difficult for some of these. I know on the radio telescope, for example, quite a lot of images you could put in. You're going to have to be quite smart about how you add information to a single frame. You don't want to have a single frame for each single line graph or scan. So you might have to think a little bit about that. But I think, all in all, a standard experimental write-up. It's the first one. The word limits will not be policed too heavily. Next time we will be penalising if you go over the word limits. For this, I think we're going to be a little bit forgiving. But just see how you get on and get that right. That's question one. Question two is a bit more like what we've just been asking. It's about a public engagement event. I guess you've done public engagement events, Ulrich?
Quite a few, indeed.
What sort of tips can you give to people who might be charged with doing public engagement events?
We usually supply access to one of our instruments there, in order to make this worthwhile and effective. The key is a large display screen. If you have it on a tiny one, it's only good for one person right in front of it, and anyone else listening to what you explain is lost because they can't see what's going on. It's also a good idea to have not just one screen, but as many as you can get hold of, because there's always many things to be displayed in parallel. Certainly if you want access to a facility and show this. You also want some plan for what you want to present to begin with. So you need to make up your mind if this is meant to be an interactive display where you ask people to do something, or if it's just something you talk over and demonstrate. Typically the best one is with involving visitors to the stand or to the event with some sort of activity, but which might be hard if it's a lot of people coming. But it's be creative, think of ways to do this.
I guess people like to see the telescope as well, not just see through it, but see it as interested in the instrumentation.
Clearly for this, you could either have a webcam view of it, which if it's live, or if you don't have this, you should have images, photographs of the facility in different stages of use, inside out, open, closed.
Right.
Ideally complemented by some display on results it produced or images it took. And then obviously also information about where it is sited and what it's used for. So maybe a poster board explaining this in addition to any screen and live stream is a good idea.
Okay. Any thoughts, James, about what you would do if you were putting Arrow into a public display or something?
Well, I think you need to think about, for example, radio astronomy. Our observing sessions were during the day as well as the evening, so there's an opportunity to do some live astronomy during a daytime event.
Better start, you could even do it in parts of the country where it's wet, because we've got John Baxter saying that when he took his readings on Arrow, it was
Absolutely,
raining.
yeah. I mean, I've taken part in some outreach events at optical observatories during the night when it's been cloudy, so you can perhaps shift your focus about what you talk to people about. Obviously, then you talk more about the equipment and perhaps the dome, let people move the dome, things like this, show them some images taken on clear nights. So I guess for that sort of thing, you have to have a backup plan. If you're
Always have a
thinking of
backup plan, yes.
If you're doing anything live.
Like working with the internet. Can we move around a bit and get these lights to stay on? Right, okay. We should be all right for another 2 or 3 minutes, I think. Okay, well, thanks for those tips there that might be useful for the TMA. I'd perhaps just take a moment now to say what we're going to be doing next after you've got a week of TMA and reflecting, and there are some reflection questions that have been designed to help you think about what you've done. It's a bit like turning around and looking down the mountain when you're climbing mountains, just to get some sense of progress, to see how things are developing. There's a skills portfolio which we're asking you to assemble throughout the module, and now you've got some practical science under your belt as part of this module, you'll have some things that you can put in the skills portfolio to illustrate, for example, how you're using ICT, or how you've been collaborating with other researchers, or how you're writing technical reports. So have a look at the skills portfolio as well while you're reflecting next week. It's not just writing the TMA. But on Saturday anyway, this week, we will be opening up what's going to come next. The forums won't be open until a week on Saturday, when the next topic starts for real, but we'll open up the study materials, and you will see that Probing the Electron is the general title. You'll see that already. And there's a nice little introductory video to that. These little videos we put in are designed to give you something to look at in advance, so that you can see what's coming up. And if you're off doing something else for 2 or 3 days and you just need to get back into the subject to get your study started again, have another look at the video. None of them lasts more than about 4 minutes. And they just help you focus again and get the big picture, so that you can see why you're doing the detail that you're doing. The detail in Probing the Electron is about a couple of fundamental measurements. If you can measure on a fundamental particle like the electron its charge and its mass, then you're a long way to understanding its properties. Those are key, and every electron has the same charge and the same mass. So we've got some experiments for you to do, in which first of all you measure the charge to mass ratio of an electron, and then we do a measurement that leads to the rest mass of the electron. So once you've got charge to mass ratio and rest mass, then you have those 2 fundamental quantities for the electron. If we had time, we could go on and do more fundamental particles, but I'm afraid that's all we've got time for. It'll be a 6-week period doing that. And then there'll be some more work on the portfolio and some nuclear magnetic resonance work as the final topic before we go into our team project, collaborative team project. Perhaps in the next Labcast I'll do a little bit of looking forward to that. Now, we're drawing towards the end of our half-hour slot, which is what we kind of allocated for this. I think it's a reasonable time. Thank you for joining us for that. There's another widget to look at to take us towards that. And in that widget, I think we were asking what you thought the premier observatories were. So let's see what we've got. I'm going to read off what I can see here. Hawaii, yes. Where is Keck?
It's on Hawaii.
Okay, we've got Keck and Hawaii, so that's an extra vote for Hawaii. Chile, Alma. Where's Alma?
In Chile.
In Chile,
well,
good,
yeah.
okay. Jodrell Bank, More funding.
That's a good one. I like that very
That's
much.
good.
Yes.
That's good. Oh, there's another Chile one because Chile Atacama.
Yep.
That's where Alma is, isn't it?
The Atacama Desert is
Yeah.
the wider region where
Yeah.
all these observatories are. Yep.
Yeah. Okay. Kielder.
That's a UK-based one, a very active one, very nice one.
Yeah.
Certainly premier in terms of outreach and reach.
Is that Kielder in the Kielder Forest?
Most likely, yeah.
Northern
I
England?
think so, yeah.
Chile there.
Mhm,
Yeah.
mhm.
Okay. Arizona. What have we got there?
Is a good place. There's Kitt Peak.
Yeah.
Mhm.
Okay. And there's one where the writing's got very small, so I have to
Yeah,
lean
can't
in
read it.
to read it. More acknowledgements. What? That's not a Premier Observatory. Right. I'm just going to see if there's any question on the chat coming through here. Just wondering if Hubble has replaced large amounts of Earth observation, of Earth-based observing. Now, that's a good question. Excellent question. And Ulrich knows the answer.
It did not replace any work from Earth. It is certainly true that Hubble is fortunate because it is above the atmosphere, not suffering from seeing induced degradation of the image. However, since Hubble was launched, the technology moved on, and most, if not all, of the larger telescopes now on Earth have adaptive optics and can compensate effectively for seeing effects, and so they achieve image quality which rivals or surpasses that of Hubble, combined with the fact that Hubble is a fairly small mirror in nowadays currency. I would say Hubble is aging, and in fact there are new satellite observatories being constructed and built which will replace Hubble sooner or later. Hubble still is, however, a very important instrument and is still delivering very, very worthwhile data, and we all hope for it to continue to work for as long as possible. It did survive for much longer, I think, than people had thought it's possible already. So it is a big success. But it's not quite true to say it replaced or made Earthbound observatories obsolete. They moved on a lot since Hubble's launch as well.
Yeah, okay. Thank you. Very nice, thorough answer there. Another question here. Alexander Rawlings is asking, how do you think the skills that are developed during the module using robotic telescopes translate for somebody if they were then to go from doing internet control to being at a telescope?
Yeah, I think all the generic skills you learned here, you will need when working with a professional telescope as well. You need to be aware of common problems while data are being taken, such as effects from seeing again, from not really well working, focusing, from tracking errors. You will need to be aware of the need to calibrate your images. There will need to be flat fields taken, dark and bias frames taken. That's all the same. The control as such is most likely different. There's a different interface. It won't be ACP, but you still have to specify the coordinates, the length of time you want the exposure for, and other details and filters. So it is, in that sense, very, very similar. However, it has to be said that the Q-scheduled large telescopes where you prepare a request work more like the BRT, the Bradford Robotic Telescopes, the large telescopes. You are not in control of the telescopes in real time, but you have to prepare a request which is fed into a queue and then executed at the ideal time of night or day, not day, night, time of a month. For telescopes where people still travel to conduct the observing runs, there I think the experience might be quite similar to Pirate, because there you are in the control room looking at interfaces which may be in detail a little bit different from ACP, but ultimately will tell you in a similar way what the telescope is up to. It's just that you are most likely in a control room not too far from the instrument, and you can in principle pop out and have a look at the sky to see if it's, oops, is there a cloud in the way, or why is there now data appearing on the screen?
Okay, thank you for that. James, about a radio telescope, how does the experience of Arrow compare with working on a radio telescope?
Well, I think it's very much similar to what Ulrich has just said, really. I mean, you are pretty much either submitting batch jobs to be carried out at a later date, or you are in a control room using a PC near to the radio telescope itself.
But the kind of interface that you have wouldn't be terribly different from, or a bit more complicated perhaps.
It would be more complicated, perhaps more functions and more parameters to set, but the basics are the same as Arrow.
Okay. I think we'll just take one more question. Tamsin has asked about becoming a professional astronomer. Ulrich, you're a professional astronomer. How did you become one?
Well, I got my degree, I did a PhD, I applied for jobs. That's how you become an astronomer. It takes...
The PhD is part of it, you think?
Yes, I mean, if you want to become a professional astronomer and want to have a job in this field, you have to do a PhD, I think, after your first degree, so that should be your target. While doing a PhD, you will be pretty much exposed to what professional astronomers do on a daily basis, and that is then a very good period where you could decide if this is really something you want to do for a living, forever, or if the taste of a PhD of 3 or 4 years is the experience you wanted, and then you can take it away and say, I have done it, and now I find different things to occupy myself. So, but PhD is what you should look for. So,
and everybody's got one. So, a good PhD if you want to. Because
right,
I guess
so
not everybody who does a PhD ends up in astronomy.
No, that's sadly true, and links to more funding, which we saw on one of these interfaces. Astronomy obviously can only take so many staff, so many astronomers. Funding is limited, and it will be ever more limited in future, or in the near future. So it is a highly competitive profession, and you have to be prepared to be very flexible and adapt to the job situation if this is what you're looking for. If you're looking for earning a living as an astronomer, the best advice is be flexible as to where you want to work. It is a global profession, and you could end up in any country on the globe.
Okay. I should say that I know several people who were astronomers who are now earning quite a lot of money doing computer programming in the city and places like that, and getting quite a lot more than they would have been if they'd been staring at the stars still, which they can still do if they join in Open University activities such as Pirate or visit the Bradford Telescope. There we are. Now, there is a post-Labcast discussion forum set up. Thank you, Peter, for setting that up. That's great timing. And I'm just reading a couple of other messages here. Well, you're talking to each other, so it's fine. I don't mind that. I think we're going to draw this to an end. Thank you for joining the Labcast. I'm sorry it was short notice. We weren't sure that we could get the technology of Labcasting to work before, well, round about Wednesday, we were absolutely certain that it was going to work. And then, even then, when we got here, we weren't sure that the networks here would support it. We know that we have to keep moving to get the lights on, and thanks for your patience over that. I'm sorry about the sound, and my laptop sounding as if it's taking off. We've learned a little bit about that too. And it's been great fun to be able to be here and to share the being here with you. So thanks for joining us, and join us in another Labcast in a few weeks' time.
Thank you, and good luck with the TMA.
Thank you very much. Good night.
Okay, we're going to stop the streaming now. Streaming, not the screaming.